Hello students, welcome to the new module of our chapter called electrostatics. Now students, in the previous module we have already learned the statement of Gauss theorem. Yes, after that we have written the mathematical statement of Gauss theorem. Now students, in this particular module we'll be proving that mathematical statement of Gauss theorem. Yes, we'll be starting with proof of Gauss theorem. Right, so let us start. Now students, in the previous module we have learned that Tn Ei over a closed surface, it is equal to summation I is equal to 1 to n qi, right? And what does this summation I is equal to 1 to n qi represents? This represents the total enclosed charge, right? Now students, we have learned formula for Tn Ei, right? What's the formula? Formula is integration over a closed surface epsilon E cos theta ds, right? So I'll be putting this value in this equation. So what will I get? I'll get integration over a closed surface epsilon E cos theta ds, it is equal to summation I is equal to 1 to n qi, right? Now students, this particular term summation I is equal to 1 to n qi represents total number of enclosed charges. So for simplicity, we'll prove it for only one charge, or rather we'll enclose only one charge, that is charge plus q, right? So in this particular case, we need to prove integration over a closed surface epsilon E cos theta, it is equal to q, right? Where q is the only enclosed charge. Now let us see the steps that we'll be using for the proof of Gauss theorem, right? First step, we need to consider any charge plus q and we need to place it at point O. Second step, we need to enclose this charge by any arbitrary surface. And third step, we need to consider small element and we need to find electric field intensity for it, right? Next step, we are supposed to find Tn Ei for an element, right? The next step, we are supposed to put the value of intensity from step 3 in step number 4, right? Next step, we are supposed to separate solid angle and will replace it by term called d omega. And last step, will integrate Tn Ei of the element to find Tn Ei of the closed surface, right? So let us start with the proof of Gauss theorem. Now let us start with the first two steps, right? We need to consider any charge plus q at point O and we need to enclose this charge plus q by any arbitrary surface. So let's say we are having charge plus q at point O and we have enclosed it by the surface. And this particular surface which is enclosing the charge, it is referred as Gaussian surface. This we have learned in the previous module, right? Now let us move towards step 3. Now let us consider small element AB on the Gaussian surface which is having area ds, and let's say capital P is the center of this particular area, right? So we are having AB as element having area ds, and let's say capital P is the center, and we are supposed to find electric field intensity for this point P, right? Now students, now this charge plus q is acting as a source charge and this will produce intensity at point P, right? So therefore the magnitude of intensity at point P is given by, so first of all we'll consider distance between point O and P as r, right? So the formula for intensity will become E is equal to 1 by 4 pi epsilon q upon r square, where r is the distance between charge plus q and point P. Now students, this element AB is very small. So I can say every point on element AB will be nearly at the same distance from the charge q, right? And as it is at the same distance, so I can say this formula of intensity will be applicable for every point on the element, right? Or I can say here the element AB is so small that every point can be supposed to be at the same distance r from charge plus q, and that's why this intensity is same. This intensity is same for every point on the element AB, right? Now let us move further. Let us start with step number 4. Here intensity will be directed outward since it is a positive charge. Let us consider area vector which is vector ds, and let's say theta is the angle between them. So what will be normal component? In this case, normal component will be E cos theta, right? Now let us move towards step number 4 and let us find Tn Ei for the element. Now student, we know formula for Tn Ei, right? It is given by integration over a closed surface epsilon E cos theta ds. But while calculating for the element, we'll not consider the integration sign, we'll only consider epsilon E cos theta ds, right? So therefore Tn Ei of element, it is equal to epsilon E cos theta ds. Now let's move further. Let's put the value of E in it, right? So after putting, I'll get epsilon into 1 by 4 pi epsilon q upon r square cos theta ds. Now let's move further. We'll cancel out epsilon, right? And lastly, we'll separate solid angle and we'll replace it by d omega. What is value of solid angle? It is ds cos theta upon r square, right? And this solid angle is getting formed at the center, and it is getting formed because of the small area, right? So let us write. So I can write TNEI of element. It is equal to q upon 4 pi cos theta ds upon r square, and this cos theta ds upon r square is the solid angle, and we'll replace it by d omega. So therefore TNEI of element, it is equal to q upon 4 pi d omega. Now last step, we need to integrate this TNEI of element to get TNEI of the closed surface. So let's integrate. Right now students, q upon 4 pi is constant. We'll take it out of the integration sign, so we'll get q upon 4 pi integration of d omega, and this integration of d omega is nothing but the total solid angle which is getting formed at a point, and the maximum value of solid angle which is getting formed at a point is 4 pi, right? So if I put 4 pi, what will I get? I'll get q upon 4 pi multiplied by 4 pi. I can cancel out 4 pi. So what will I get? I'll get TNEI over a closed surface, it is equal to q. So students, in this particular module we have proved that total normal electric induction over a closed surface, it is equal to q, which is the only enclosed charge in this particular case, right? Now let us see a very important point. Now let's say if we are enclosing n charges, let's say we are enclosing charges q1, q2, q3 and qn, right? Then TNEI is given by q1 plus q2 plus q3 up till qn, or it can be written as summation I is equal to 1 to n qi, right? And this particular statement we have learned in the previous module itself. So students, in this particular module we have proved Gauss theorem mathematically. So students, that's it for this module. I'll see you in the next module. Till then, keep learning.